Vanakkam. Understanding the anatomy of the extensors up to the level of the metacarpophalangeal joints of the fingers is quite simple and easy. But what happens after that? They call it the dorsal expansion, they call it the extensor hood, and so many other names. Is it so difficult to understand this part of the anatomy of the extensors? Definitely not. The easiest way to solve a big problem is to break it down into much smaller problems and then solve each of them one by one. And that is what we are going to do today in this video on understanding the dorsal apparatus on the finger. The intricate system of muscles, tendons and ligaments on the dorsum of the fingers is called by various names: the dorsal aponeurosis, the dorsal apparatus, the dorsal expansion, the dorsal hood, and sometimes the dorsal mechanism, or even extensor aponeurosis, extensor apparatus, extensor expansion, extensor hood, or extensor mechanism. For sake of simplicity and understanding, we shall call it the dorsal extensor apparatus. So, the intricate system of muscles, tendons and ligaments on the dorsum of the fingers is the dorsal extensor apparatus. But what is the purpose of such an elaborate system? There are four important purposes of this dorsal extensor apparatus: to provide mobility of the joints of the fingers, to coordinate between the movements occurring at the metacarpophalangeal and interphalangeal joints, to maintain a balance between the multiple forces acting on these joints, and at the same time ensuring stability of the joints in movement and prehension. So as far as the function of the dorsal extensor apparatus is concerned, we need to remember only four words: mobility, coordination, balance and stability. So today we are going to look at the anatomy of the dorsal extensor apparatus. But looking at the gross anatomy, this is how we find it, and it looks complicated. So we shall simplify the anatomy, and to make it simple to understand this apparently complicated structure, we shall divide it into 6 small parts and discuss each in detail. So we shall learn the complete anatomy of the dorsal extensor apparatus by studying the 3 muscles and tendons that make up this apparatus, the 3 parts of the apparatus, the structure of the central tendon, the structure of the terminal tendon, the extensor hood formation, and the retaining ligaments that take part in this dorsal extensor apparatus. First, we shall see the 3 muscles and tendons that contribute to the dorsal extensor apparatus. They are the extensor digitorum communis, the interossei, and the lumbricals. Let us now see the extensor digitorum communis and how it participates in the dorsal extensor apparatus. The entire dorsal extensor apparatus is placed over the distal part of the metacarpal bone, the proximal phalanx, the middle phalanx, and the proximal portion of the terminal phalangeal region. The main contribution of the extensor digitorum communis is over the dorsum of the head of the metacarpal and the proximal phalangeal region. When I say the extensor digitorum communis, I am also referring to the contribution of the extensor indicis proprius for the index finger and the extensor digiti minimi for the little finger. And for purposes of understanding, we shall consider the left ring finger, where the contributions of the dorsal and palmar interossei along with the lumbrical can be denoted. The extensor tendon, as it crosses the metacarpophalangeal joint, it is covered by the sagittal band, which we shall see later. At the level of the middle to the distal portion of the proximal phalanx, it splits into 3 parts: the lateral slip on the ulnar side, the lateral slip on the radial side, and the central slip. We shall see what happens to these structures as we go along. The actual insertion of the extensor digitorum communis is quite complicated, and we shall see that after we finish describing the anatomy of the 3 muscles and tendons. Since the extensor digitorum tendon splits into 3 at the level of the proximal phalanx itself, the main force of the extensor tendon is spent on the dorsum of the metacarpophalangeal joint. Hence, the extensor digitorum tendon acts mainly on the metacarpophalangeal joint by extending it. Now we shall consider the contribution of the intraossei and lumbricals to the dorsal extensor apparatus. Since we are considering the dorsal aspect of the left ring finger, we have the dorsal intraosseous on the ulnar side entering the apparatus, and on the radial side we have the palmar intraosseous muscle. This muscle traverses on the dorsal aspect of the deep transverse metacarpal ligament, and the lumbrical muscle, being on the radial side of all the fingers, is entering the dorsal apparatus volar to the deep transverse metacarpal ligament, as has been shown. It joins with the intraosseous tendon to form the lateral tendon. So now we have two lateral tendons, one on the ulnar side and one on the radial side. These two lateral tendons now split into two each. These are called the lateral intraosseous band and the medial intraosseous band. Please remember that this lateral and medial are named with reference to the dorsal axis of the finger. As we had said for the extensor tendon, we shall consider the insertion of the intraossei and lumbricals after the complete description of the dorsal extensor apparatus. The main function of the intraossei insertions are flexion of the metacarpophalangeal joint and extension of the proximal and distal interphalangeal joints. Now we shall see the formation of the three main parts of the apparatus: the central tendon, the terminal tendon, and the extensor hood. We shall now see how the central tendon is formed from three structures: the central slip, the medial intraosseous band on the radial side, and the medial intraosseous band on the ulnar side. We have already seen how the central slip was formed from the extensor tendon and how the medial intraosseous band was divided from the lateral tendon. The central slip joins with the two medial intraosseous bands coming from the radial and ulnar sides to form what is known as the central tendon. This central tendon inserts into the base of the dorsal aspect of the middle phalanx. The forces applied through this central tendon extends the proximal interphalangeal joint. Now we shall see how the terminal tendon is formed. There are two structures contributing to this terminal tendon: the conjoined lateral band on the radial side and the conjoined lateral band on the ulnar side. The last we had seen of the lateral tendon, that is the intraosseous and lumbrical tendons, was it had split into two, that is the medial intraosseous band and the lateral intraosseous band. The medial intraosseous band has joined with the central slip to form the central tendon. The lateral slips arising from the extensor tendon join with the lateral intraosseous band on the corresponding sides to form what is known as the conjoined lateral band or tendon. These two conjoined lateral bands are placed on the dorsum of the proximal interphalangeal joint on either side of the central tendon. The conjoined lateral bands or tendons from both the radial and ulnar sides move distally over the middle phalanx, and at the level of the middle to the distal third of the middle phalanx they join together to form what is known as the terminal tendon. This terminal tendon inserts into the dorsum of the base of the terminal phalanx. Now we have what is known as the extensor hood formation, which is formed from two structures: the transverse lamina and the oblique lamina. The extensor hood is nothing but a thin filmy aponeurosis that extends from the lateral tendon, that is the intraossei and lumbrical tendon, from the radial side to the ulnar side. So it covers the lateral and dorsal aspect of the proximal phalanx of the finger. The proximal fibers run transversely over the proximal phalanx. This is known as the transverse lamina. Distal fibers run obliquely over the distal part of the dorsum of the proximal phalanx. So this is known as the oblique lamina. These transverse and oblique laminae contain the complete formation of the extensor apparatus within them. These two structures, that is the transverse lamina and the oblique lamina, are known as the extensor hood. Though it is the interossei and lumbricals that are the actual motors, the transverse lamina and oblique lamina give the mechanical advantage to flex the metacarpophalangeal joint and extend the proximal interphalangeal joint. We have now seen the formation of the dorsal extensor apparatus, but there are important structures required to maintain the position of the apparatus, and these are known as the retaining ligaments. We shall see about the formation of three retaining ligaments: the sagittal band, the retinacular ligaments, and the triangular ligament. The sagittal band consists of thickened fibers arising from the volar plate of the metacarpophalangeal joint of the finger, moving dorsally, encircling the extensor tendon and getting attached to the volar plate on the opposite side of the finger. This can be well understood by a cross-sectional view of the metacarpophalangeal joint, that is the metacarpal head, and the extensor tendon on the dorsal aspect has been shown. This is the volar plate of the metacarpophalangeal joint and the deep transverse metacarpal ligament arising on the side of the volar plate. The sagittal band arises from the volar plate, moves around the metacarpophalangeal joint to the dorsal aspect and encircles the extensor tendon. The lateral view also shows how the sagittal band hugs the metacarpophalangeal joint on either side, holding the extensor tendon in place on the dorsal aspect and being attached to the volar plate of the joint on the volar aspect. The sagittal band plays an important role in the function of the extensor tendon. It stabilizes the extensor tendon over the metacarpophalangeal joint, and this is done passively. Secondly, it extends the metacarpophalangeal joint during hyperextension by applying traction through the sagittal band. And thirdly, it controls proximal excursion of the extensor tendon. Just imagine this paper is like the extensor tendon balanced over the head of the metacarpal. It can slip on either side. To prevent that from happening, when I hold my hands over it, it stays stable, and this is what the sagittal bands do. What my hands are doing, stabilizing the extensor tendon over the head of the metacarpal. Having learned about the sagittal band, we need to learn another important set of ligaments, the retinacular ligaments, consisting of the transverse retinacular ligament and the oblique retinacular ligament. The transverse retinacular ligament is located on the lateral aspects of the proximal interphalangeal joint and arises from the volar plate and fibrous flexor sheath and is attached to the lateral tendon of the extensor apparatus. So this lateral retinacular ligament does exactly the same work as is done by the sagittal band. So when the proximal interphalangeal joint extends, the transverse retinacular ligament prevents excessive dorsal shift of the lateral bands, and when the proximal interphalangeal joint flexes, the transverse retinacular ligament pulls the lateral bands volarly over the proximal interphalangeal joint and allows the flexion to proceed. We can understand this better when we consider the pathological conditions. When there is an attenuation of the transverse retinacular ligament, there is an excessive dorsal position of the lateral bands which may predispose to the swan neck deformity. And when there is a tightening of the transverse retinacular ligament, excessive volar position of the lateral bands is seen, as in boutonniere deformity. Here, the tightening of the ligament could be due to the boutonniere deformity, or the tightening of the ligament can lead to the boutonniere deformity. The oblique retinacular ligament is a ligament that crosses two joints. It crosses the proximal interphalangeal joint and the distal interphalangeal joint. We need to note that it crosses the proximal interphalangeal joint volar to the axis and crosses the distal interphalangeal joint dorsal to the axis. and it is attached proximally to the fibrous flexor sheath and the lateral aspect of the head of the proximal phalanx and distally attached to the base of the terminal phalanx on the dorsal aspect. The main function of the oblique retinacular ligament is to link the proximal interphalangeal joint and distal interphalangeal joint movements. When the PIP joint is flexed, the ligament relaxes, allowing the DIP joint also to flex. When the PIP joint is extended, the ligament tightens and helps in the DIP joint extension. The oblique retinacular ligament is represented by the line I have drawn, that is, dorsal to the axis of the DIP joint and volar to the axis of the PIP joint. When the PIP joint flexes, it allows flexion of the DIP joint, and when the PIP joint extends, it helps in the extension of the DIP joint. When pathological changes occur, there are characteristic deformities that are formed. If the oblique retinacular ligament is tight, it causes a boutonniere deformity, hence it must be divided. On the other hand, in a swan neck deformity, this ligament is loose and hence it must be reconstructed. The triangular ligament, as the name suggests, is triangular in shape and present on the dorsum of the middle phalangeal region of the finger between the two conjoined lateral bands of the finger. This triangular ligament serves to stabilize the extensor over the middle phalanx and prevents volar migration of the conjoined lateral bands on either side. Having learned about the complete anatomy of the dorsal extensor apparatus, we shall now see where the extensor digitorum tendon is actually inserted. It has got four main insertions. The first is insertion of some fibers into the sagittal band. The second is insertion into the base of the proximal phalanx, but this is variable. Insertion into the central tendon through the fibers of the central slip, and lastly insertion into the terminal tendon through the fibers of the lateral slip. As far as the insertions of the interossei and lumbricals are concerned, there are three types of insertion. There could be a proximal insertion, distal insertion, or mixed insertion. The first dorsal interosseous muscle has a proximal type of insertion where it is inserted into the interosseous hood or extensor hood, into the volar plate and the base of the proximal phalanx on the radial side. The distal insertions occur with all the palmar interossei muscles and the third dorsal interosseous muscle, that is, insertion into the central tendon through the medial interosseous band and insertion into the terminal tendon through the lateral interosseous band. The mixed type of insertion, that is, both proximal and distal, are characteristic of the second and fourth dorsal interossei muscles. A quick recap of the anatomy of the dorsal extensor apparatus. The extensor digitorum communis crosses the metacarpophalangeal joint on the dorsal aspect, splits into the central slip and two lateral slips. The interossei and lumbricals join together on the radial side to form the lateral band, and on the ulnar side the interosseous continues alone as the lateral band. The lateral band splits into the medial interosseous tendon and the lateral interosseous tendon or band. The lateral interosseous tendon joins with the lateral slip to form the lateral conjoined tendon, and the central slip joins with the two medial interosseous tendons to form the central tendon that inserts into the base of the middle phalanx, and the two lateral conjoined tendons or bands join together to form the terminal tendon which inserts into the base of the terminal phalanx. The transverse lamina covering the proximal aspect of the proximal phalanx and the oblique lamina covering the distal aspect of the proximal phalanx, the sagittal band enveloping the lateral and dorsal aspects of the metacarpophalangeal joints and the extensor tendon, and the triangular ligament between the two lateral conjoined tendons on the dorsum of the middle phalanx. Looking at it from the lateral aspect, the extensor tendon crossing the metacarpophalangeal joint and the lateral tendons formed by the interossei and lumbrical muscles, the insertion of the central tendon into the middle phalanx and the insertion of the terminal tendon into the terminal phalanx, the transverse lamina, the oblique lamina, the sagittal band at the level of the metacarpophalangeal joint and the triangular ligament over the middle phalangeal region, the fibrous flexor sheath on the volar side from which arises the transverse retinacular ligament which is attached to the lateral bands, and the oblique retinacular ligament that is connecting the distal interphalangeal joint and the proximal interphalangeal joint. I hope you liked the video. I enjoyed making it. Please click on the shown link to see more about the extensor's anatomy of the forearm and hand, not only the structural anatomy but also the functional anatomy and the surgical anatomy. And do not forget to subscribe to stay connected with the latest in learning hand surgery. Vanakkam.